Hello and welcome to the eTech podcast with me, your host, Ryan Maughan. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. For today's show, I'm joined by Lars Stegmann, who is the CEO at a fascinating company called CapX. Welcome to the show, Lars.
Thank you, Ryan.
I wonder if we could just start out by learning a little bit more about you and your background and how you came to be doing what you're doing now.
Sure, yes. After university, I started in 1998 already in the passive electronic combined with power electronics and joined this market quite a while ago, 25 years already. I was in contact with CapX years before, around 2011. I met with the former CEO, Anthony Congrads, on different kind of trade shows or even events where we talk about technology and renewable energies and so on. In 2023, with the reason Anthony retired, they come along myself and ask myself if I'm interested to take this challenge and lead CapX. And as I know this company, it's a fantastic company, I said yes. Yes, it's a challenge. It's good.
And are you an engineer by background? Is that your sort of training, or are you more of a business person?
Good question. I'm an engineer. I joined the university in Germany. I started in Germany and finished this in Norway.
Was it electronics that you studied at university?
It was power electronics instead, let's say, indeed. I was concentrated on power. My background is also in communication electronics, but at the university time, I joined mainly in power electronics.
And then I wonder if you could tell us about CapX. What is it that the company is doing?
A lot of people think CapX is a startup company, just started in the market with their products, but it's not. So going back in 1993, the first supercaps are, let's say, born and presented to the market as a brief product. Let's say CapX is a spin-off out of the university in Australia. In 2000, the company really kicked off to start with established products into the market. That means we know already, or we think to know what we do, and we made already our experience here. So we become an established leading supplier in this technology. On top of this, because we are a spin-off out of the university, we have a really strong IP position with our technology.
And is it a manufacturing business, or are you sort of developing technology and licensing it to others?
This makes it so interesting. You're totally right. We are manufacturer, of course. We do have these under our own control. But by side of this, we have a very strong R&D section with our own PhDs who are working on science to try to develop and improve our, let's say, current products, or develop further ideas in that direction. And with these, during time, we also license our IP to manufacturings like Murata for small prismatic supercaps, and also to AVX or TDK.
Oh, wow. So a bit of manufacturing and a bit of licensing as well.
Exactly. This is the core of our, let's say, the core idea of our company. So we have our own manufacturing, our own development, but also we license this to, let's call it a kind of competitors, right? Business. I would call them market partners, business partners, because we are playing in the same playground and the same market. But as you can imagine, the others do have a really big sales force and another market access than us.
Yeah, well, they don't really, you mentioned a couple of pretty big names there, but in the world of capacitors, I'm not sure they get any bigger than Murata. They're an absolutely huge company making an awful lot of passive components and things like that. And one final question on the company. Whereabouts are you based?
Yeah, good question. And many people do not think about, but we are based in Australia, in very close to Sydney. We call it, let's say, Sydney, but it's a town called Seven Hills. It's 35 kilometers outside of Sydney. very close, very convenient to reach from the airport, etc. So no, it's a very nice location, and a lot of people do not estimate the industry which is established in Australia. Or always people think about holidays and beaches and such kind of things, but no, it's not. There's also some business.
Oh wow, okay. And personally, are you in Sydney? Is that where you're living?
In 2006, Capex got listed on the AIM, the Alternative Investment Market, on the London Stock Exchange. And with this change in the CEO position, we want to make sure that the new CEO is closer to the stock market, so it's more reachable for our investors, which most likely in Europe / also New Zealand and Australia. But to be closer to the market, I fit exactly in this position because I'm based in Hamburg. Most likely I'm traveling. So I'm normally say I'm based in an airplane.
You made that comment before we started, but the relevance of that didn't quite drop until just now. We talked now a bit about actually just understanding what the company does, and I think it's going to be helpful for people just to have a little quick recap on actually what is it? What is a supercap? When you say that, what do we mean?
Everyone may remember the physics lessons in school. Some hate it, some like it. And most likely during these times, you reach automatically the section of capacitors, which are the normal small energy storage. This is the main idea, to keep amount of energy which are recharged very quickly and discharged very quickly as well. So with this supercap, as the name says, has more power density, but the feature of the capacitors. So that means we get charged really quickly, in milliseconds or even quicker, but this charge controlled by software could be quick, but you could also control the discharge with your device. So this makes our technology so interesting, especially during this time where we do have this change in energy management, battery management, renewable energy, such kind of thematics.
If you had to kind of like in one sentence, might not be possible, but could you try, what is it that makes a capacitor a super capacitor rather than just an ordinary capacitor? Is it the size or the capacity or the speed at which it can charge, or? No. It's a combination.
But you're right. It's a combination of all of this. Let's say the supercapacitors are able to store more energy in that device than the capacitors do it normally, right? So if you have a normal capacitors running in microfarads range, so we dancing in farads, right? So microfarads. This is our playground. So we are much bigger in the capacity than the normal capacitors.
And is there a particular kind of construction or sort of chemistry that, I mean, a lot of the listeners are from the electronics domain, so they'll be familiar with different kinds of capacitors and electrolytics and film capacitors and all that kind of thing. Is there a particular kind of construction and chemistry that defines your supercaps?
Yeah, a lot of suppliers on the market, and we specify our products with our IPs and our technology. So we are concentrate on the electric double layer capacitors. This is the architecture we work with. Gives us, based on the technology, a lower ESR, higher voltage, higher capacity, and even with these, a wide range of temperature, right? So we start with minus 40 degrees and goes up to 85 with our high temperature supercaps. So this is a quite good range where you can serve the market with a lot of application, right?
What sort of applications are they? Are we finding supercaps in kind of everyday products now, or is it sort of special applications?
It could be an everyday product. It's not yet there because the use of a normal battery, a coin cell battery or other batteries, are more easy and known. The development of batteries in the market, the acceptance of a battery, for example, in your car, on your mobile phone, it took a while, it took time. This is all solved now. The technology of the batteries becomes better. but there's still a gap to bridge in energy, and this exactly is the bridge where we enter into the market, which is our playground to focus on. So, for example, in a car, we could take the peak loads to increase the battery life instead of get these batteries damaged by too often use in the extreme moment, right? This is a big benefit of supercaps. Another benefit is also we store our energy as it's a static charge, right? Whereas the battery use chemical reactions to store energies, right? So, for example, if you want to chip any kind of device, you don't need to label this package. You don't need to fill any additional forms. So it makes the handling of the finished good, of the consumer goods or whatever, much, much more easier than it is today.
You know, as we're kind of designing things like power converters and DC-DCs and traction inverters and things like that, I mean, those devices tend to have big capacitors in them for the DC link systems. Is that kind of application one for where you might find a supercapacitor?
It could be. Let's say it's obviously not the main market, because these capacitors also in these devices you mentioned it also fulfill other criteria. But it could combine easily with these kind of devices to store the energy and release the energy in the next moment, whereas the battery is far too slow. I mean, you remember if you recharge your e-car, it needs a while, a minimum 40 minutes to reach 80% in average, and a couple of hours if you want to recharge it for 100%. Maybe this was not super correct in the charging process, and maybe someone say, no, my charging much faster. Yes, of course, the battery technology is improving. But in supercaps, we talk about milliseconds to charge, or up to seconds to charge it, and to discharge it, so if necessary, right?
We used to hear about hybrid systems with batteries and supercapacitors together. Is that more of the application then, more of a sort of hybrid energy storage?
It could be in hybrid, like you said, if you have kind of high constant power use, like huge battery bank, but to avoid to increase this battery bank too much, you try to filter out, so to cut the peak out of these. So you put the combination of supercaps in addition. So this helps definitely. But we also see application where we do replace, or let's say do the job as a battery, like as in the consumer goods, where the energy density obviously is not so intense. For example, a key fob in a car, how often you press a button in your key fob, right? Everyone think, wow, it's quite often, but no, most like you open the car, you start your car, you stop your car. Most likely people park the car the whole day because they're in the office. So the use of a key fob, it's obviously don't need a huge energy storage inside the key. If you release the key, it's a kind of peak. It's a millisecond, maybe even less than a millisecond, where you need this power. And this is totally enough for us to use a supercap. And with a supercap, it's much more thinner, lighter. So the design of a key fob becomes more, I would say sexy to the market, right? So the designer has all freedom now to get the shape done, make it much more thinner, even like a let's say credit card, you know.
In that application, in something like a key, you need to have power over quite a long duration. So, you know, normally we think of capacitors, they sort of, you don't store energy for a long time, but you're able to store energy or charge for a longer period of time and retain it, or does it you still have the same kind of issues in terms of losing charge?
Of course, I will not say we never lose the charge, right? You will lose charge somehow always over time, but most likely we are able to keep this energy in supercaps very long. It depends on your usage out of these, right? as explained, if you press a button, if you press activate the key or the key fob, in this case, it's just millisecond. You use this and then release for a short moment the energy, but this is not the whole energy of your supercap, right? So you still have amount left in your supercap.
One of the other areas I remember people getting quite excited about supercaps for, or the other property, was that they, with a battery in something like a construction machine or a commercial vehicle with a conventional lithium battery, it was hard to achieve the lifetime that the customer might want because the battery degraded with time. In supercaps were thought of, and I'm just kind of going back a few years now, but thought of as being a technology that could offer you more charge and discharge cycles on quite large systems. Is that still an area that you see people working on?
Yes, exactly. This area we called heavy vehicle off-road. And you described the use of the battery exactly, let's say. The main bottleneck is to charge and discharge this battery so frequently that even on top with the peak loads, you harm the batteries and need to exchange the batteries after a while. And here the supercaps really help. So, for example, if your escalator turn in one direction by the diesel engine, but returned by battery / supercap section, this helps to bring your fuel consumption already down by 50% approximately. To do this only with batteries, it's not possible because the batteries are too slow to charge and too slow to give the energy back to the device. With a supercap, we are able to do so. So with a controlled mechanism, you're able to charge on one way and discharge if the escalator turns in the other direction, right?
Right, and have a much longer lifetime, I guess, than as well than you would with a battery. That kind of system. I mean, again, I'm going back a few years, but I remember those kind of things being very experimental concepts. Are they getting nearer to being in the market?
Yeah, of course. There are a lot of applications already in the market, especially in the high vehicle off-road devices, or also more coming in the marine business, because what's happened in the construction markets and in these heavy vehicle markets, there's a willingness to bring the emission down and become a green footprint. But in the marine market, there's legal regulation now out, which getting more and more strong, where the shipyards and the owner of the ship fleets need to think about the next step, because they are not able to drive only on heavy diesel, let's say, to bring the ship from A to B. So definitely these are markets where we are looking into, and happy to serve them, right? And this fits exactly in the current mindset, because we see us as a green technology, because we support here the green technology, and we are environmental friendly with that.
What is the biggest application today for the technology? Which is it in off-highway machines? Is it in shipping, or some other maybe much smaller device?
Yeah, no, it's right. Like you mentioned, the marine vehicles are. You can imagine the ferry is a quite huge device which runs in combination with batteries and supercaps, but also heavy vehicle off-road devices are heavy devices. But you also can, if you are on the construction side, you also find our technology in the mining areas, let's say underground, where you try or you have to avoid any kind of emission because you need to save or protect your people who are working day by day underground, right?
Are these all of the kind of hybrid energy storage system nature, or are there actually underground mining machines running just solely on supercaps?
Yeah, step by step, we see already new developments in the market. We see already more and more the acceptance of this technology. 10 years ago, it was seen, like you described it before, as it's a fancy new things which will not survive because there's a battery. We don't rely on batteries, etc., etc. So, in nowadays, it's completely changed the acceptance of a kind of battery combined with a supercap. This acceptance of this technology, it's much more higher than before. That's why I say the time for supercaps in the market, it's quite right now.
You mentioned that you're doing a lot of research and development in Sydney, taking the technology forwards. What are the kind of main areas that you're working on where you're developing the technology?
So in general, let's say we start to get engaged with several universities across the globe. So we really try to expand and build our network in this specific technology. So, for example, we are engaged with the university in Western Cape in South Africa. We are with the universities in Australia. We talk to universities in Canada, US. So all these are really progressing because if you combine the knowledge out of the universities, you get automatically the next level where you get use of kind of different material mix. What it does for us, for CapEx, our products get more powerful. With our prismatics, we are already really the form function factor. It's quite unique. It's light, thin. The application is easy to handle, and that's why, let's say, this knowledge combined with our manufacturing background helps us to establish new products regularly, right?
Do you see things like product cost kind of optimization coming through there, or are you still managing to? A capacitor is, they're very, very mature technology, and a supercapacitor, I'm not sure. I guess there's more opportunity to make supercapacitors better and improve them. Do you see big advancements coming potentially in things like performance and energy charge density, things like that?
Yeah, exactly. With more acceptance in the market and with more application where our technology stepped in, this will lead automatically our production volume in another range, so in a higher level, which I like as an operation manager in this case, because with a higher output, with a regular production of one device, you also are able to optimize the cost structure, and in the end, the price into the market. So if maybe the supercaps today are a little bit more expensive, this price will come down in a reasonable time, like we saw that on PV modules. Even the battery banks becomes more reasonable today instead of, remember 10, 15 years ago, a battery bank was the killer in a kind of energy storage.
Today, you have kind of hybrid battery systems in off-highway, underground mining, etc., as main kind of applications. I can imagine they're such big machines that you don't have to have a big quantity of machines to have a lot of volume of product needed. Where do you see the business going in the future? What kind of applications do you think coming through?
At the moment, we see a huge interest in, like you said, in the automotive / heavy vehicle market, in the marine market. But we see upcoming projects in the medical market more and more where we really work the interest and fulfill this specification. By side of these, more and more consumer products jumps on this kind of energy storage on our supercaps. The bottleneck, like we described before, the consumer products also under price pressure to sell their units into the markets. At the moment, we see us more on the prime end consumer devices and not on the, let's say, cheap mass market, let's say.
You do see a transition going from, let's say, relatively niche applications like mining equipment into more mainstream, like consumer electronics.
Yeah, exactly. No, you made it right.
So on the automotive side, do you see the potential for supercaps to become integrated into more mainstream vehicles as well?
Yes, it starts already with application which are used, for example, I mentioned key fobs before, but also tracking systems to track your car device, where it is, even, let's say, protect them to get it done under the dashboard. Such kind of application in your interior, inside the cars, our supercaps are already in use. So all this helps to bring the future automotive car on the road, let's say, because it's a changing and challenging time.
Yeah, definitely one of the biggest times of change ever for the market. So not necessarily traction, battery, or energy storage systems, but all kind of lots of other places where you need energy storage on the vehicle. So this transition seems to be progressing nicely from niche applications into more mainstream applications, which is interesting. There's these two kind of different definitions that I hear a lot, and I'm just wondering what the difference is, or what you see the differences between what you would define as a supercapacitor, and then we see people talking about ultracapacitors quite a lot. What's the key difference between those two terms?
In short, there's not a big difference, let's say. It's, the name supercap as well as ultracup is not protected, or is not secured. So it's not a trademark. So even we have customers who call our products ultracup.
You wonder if ultracapacitors or supercapacitors in more mainstream automotive products, this might become another big area where manufacturers need to have supply chain in a similar way with batteries, where actually it's you need to have a very good supply chain that you can trust, and a lot of people are kind of bringing that kind of thing inside. Do you think that sort of thing will start to happen? Are supercaps so critical that you will see big manufacturers bring that kind of thing in-house?
The supply chain is a general, let's say, headache since years in the market. You see this in the semiconductor market as well. The beauty on CapEx is we do have production in the southern of Australia, in Malaysia, but also in China, right? But more and more we see in the Western world, our customers are really looking and asking for country of origin, not to be China. So this helps to be in Malaysia and in Australia. So for this supply chain, especially, we are well prepared. What we did in 2020, we acquired the production line from Murata to get a mass production in Seven Hills, so in Australia, done. So also here we used the establishment and availability of super modern full function production line to bring it down to southern of Australia to bring our production state of the art.
Looking forwards to the future, what have you got coming that you're most excited about over the next year or two?
First of all, the development doesn't stop, let's say. So you will hear in the press more closely. We will close a couple of patents this year. So this will be announced in December. We are heavily on R&D. We are working on several cooperation with other app science companies to combine our knowledge and our technology together to bring a unique product in the market. With this kind of development, the use of CapEx get more and more freedom and acceptance, and we are able to enter in new markets which we are may not in yet today, but in the future it's more powerful. Maybe the energy density is higher, maybe the storage time could be managed differently. What we did this year, we launched a product with like a plug and play solution. This already change the market of use it, right? So you don't need an EMS, obviously, to bring a supercap on your board. It's just a connector, and you make it in plug and play. Don't think, don't calculate. Just use this energy device, this supercap, on your motherboard.
Okay, so making it more accessible. It's really interesting. And I remember I actually do remember working on a supercapacitor energy storage system many years ago. We had some issues in terms of charge management, it's fair to say, with that system.
It could be a headache, but we try to avoid these headaches for our customers. Let's put it in this way.
Yeah, I guess it's often the problem, isn't it, with technology? It's hard to integrate. So kind of in order to facilitate the use of your technology, there's probably the same problems being solved over and over again by the end customers, that actually if you can provide a simple way of them overcoming those challenges, a dev kit or a reference design, or these things are common now, but it just helps make the technology easier to integrate. People don't buy technology, they buy solutions, I think, is the...
Exactly. Yeah, no, this is the way and the trend, like we love to think, and we more and more want to offer into the market. The solution is the key. Remember, if the first iPhone started into the market with only a glass surface, no keys on anymore. And this was totally, let's say, new for either the user as well as the production line, because now it becomes more sensitive in this kind of surface, how you protect them. And this is the same we pass through with the supercaps at the moment. So there are more and more markets are opened, and as soon as we are able to serve the market as on our best, take the headache from our customer, meet their needs, let's say, to make it easy to integrate, this is the way we need to work and serve the markets.
Do you think there's a little bit, like with battery systems, as lithium battery technology is developed, costs have come down, it's then opened up more applications where you can use battery technology, and there becomes a bit of a virtuous cycle. Do you think for supercaps you're at that kind of inflection point now where you've got designed into enough applications, you're becoming more mainstream, the costs are going to start to come down, so then it can become even more mainstream, etc., etc.? Does it feel like you're kind of at that point?
Yeah, but on the starting point, but yeah, exactly. You described it right. Let's say as soon as we are in more and more applications, this definitely helps to establish also this technology into the market in general. Yes,
because it's really difficult. I know myself, again, personal experience, but the products that you're dealing with take a long time to design and develop. It's getting that those initial programs up and running, and to a point of maturity where volumes actually really start to kick in, can be very frustrating, to say the least.
No, you're right. But if you're working in the passive electronic market, most likely it's like this. And you start on a design endpoint. Yes, you're very early involved in the process, and this takes time because it's need to pass several steps with your customers. And until it launched, let's say, in the mass production and into the market. So this could take time. So sometimes they are quick. Sometimes, you need, especially for medical applications, you need to get several kind of approval process and so on. So these need to be accepted. Luckily, we do have investors in our company who knows and understand these markets takes times. And we try to speed this process up, but it's most likely not always in our hands, let's say.
I know that feeling very well indeed. Well, thank you very much, Lars, for taking that time out today to come and talk to us. It's been really interesting learning a bit more about you and about CapEx and the kind of things that you guys are doing. Definitely a company to keep an eye on. What we'll do is we'll put some links down in the show notes so people can go down below and how you can find Lars, how you can find the company, and get some more information. But thank you very much for joining us.
Thank you, Ryan. Thanks for your interview, and have a good time. Thanks.